Dear colleagues, today I present the results of pilot study devoted to quantification of the interaction of hemosorbents with red blood cells using scanning flow cytometry. Study was conducted in collaboration of Research Institute of Clinical and Experimental Lymphology and Institute of Chemical Kinetics and Combustion named Voevodsky. Two parts of this study. The first part, this is medical part, concerning of using of sorbents in medicine, because medical sorbents mainly based on charcoal are widely used for treatment various diseases. The first of all, renal insufficiency and drug and other intoxication. Sorbents are aimed at removing toxic agents from the body and which were provided by their porous structure and the chemical nature of surface. And mechanism of action of sorbents is to fix various toxins in the porous space and remove them from the body naturally when ingested, and this type named enterosorption. And another direction at the passing or perfusion blood through columns with the sorbents, and in this way, this direction named in Russian and post-Soviet Union space hemosorption, but another word has the term hemoperfusion. And another direction is the local application of sorbents to wound, and this named vulnerosorption. And medical sorbents must be mechanically strong. It's the first requirement to this one. And another requirements, they will be compatible with biological tissues. First of all, with in case of hemoperfusion, with cells of blood, red blood cells and platelets. And our presentation devoted to interaction between sorbents and red blood cells. And from this point of view, mechanically strong sorbent with we investigate mechanically strong sorbent with improved organoleptic properties. You can see here this sorbent on the basis of gamma aluminium oxide with polybidimethylsiloxane. It has white color, and another sorbent for comparable is sorbent SUMS the first. This abbreviation SUMS the first is Siberian углерод минеральный sorbent, Siberian charcoal mineral sorbent, this abbreviation. And the aim of this study to investigate the effect of this original sorbent and sorbent SUMS the first, and their influence to biometric parameters, functional parameters of red blood cells using method of scanning flow cytometry, and this method was conducted in Institution of Kinetics and Combustion in a laboratory of cytometry. And the features of these sorbents, this one and this one, consist in this technology of obtaining of sorbent Sum the first require very high temperature, about 700 degrees Celsius, and this technology is not good and a little bit harmful for ecology. Here you can see the porous of sorbent, and this porous is comparable with another molecules of toxic agents and bacterial. Here you can see the Staphylococcus aureus on the surface of sorbent. Here you can see investigated sorbents. This is a carbon-free hydrophilic and hydrophobic sorbent on basis gamma aluminium oxide and polydimethylsiloxane, and sorbent above mentioned sorbent Sums the first. Here we present experiment, schematic installation with glass column with sorbent. The volume of sorbent about 2 grams, and through this glass column we using infusion pump with constant speed, about 4 milliliters per minute, and blood obtained from patient after joint replacement perfused through this column with sorbents, and collected in tubes with anticoagulants. After this special sample preparation of blood, function parameters were determined on a scanning flow cytometers in Institute of Kinetics and Combustion in laboratory of cytometry. Average data for 6,000 red blood cells. Here you can see the results of study of physical and chemical properties of sorbents with a grain size of 0.2 to 0.8 millimeters. Structural data on the specific surface area, pore volume, bulk weight, sorption activity by methylene blue dye, and sorption of Staphylococcus aureus are presented. You can see that structural parameters of sorbents are similar, which indicates the uniform distribution on hydrophobic ingredients, carbon and polydimethylsiloxane over matrix granule, aluminium oxide. At the same time, the sorption activity of Sums the first was significantly higher compared to gamma aluminium oxide and polydimethylsiloxane and aluminium oxide alone, with a smaller specific surface area of the sorbent. and a smaller pore volume. In terms of sorption activity, again, Staphylococcus aureus SUMS the first is significantly superior to the sorbent aluminum oxide with polydimethylsiloxane. Here you can see the data on functional parameters of red blood cells, particularly anion exchange rate and ultimate membrane extensibility, evaluated on the basis of data on red blood cell hemolysis using the developed mathematical apparatus developed in the laboratory of cytometry. And this table shows the data of number of active band3 protein and the values of ultimate extensibility of erythrocyte membrane. This is a ratio of stiffness to elasticity. And so the transmembrane protein band3 is the main exchanger of the erythrocyte, and a polyfunctional membrane glycoprotein involved in the transfer of anions through the phospholipid bilayer. In the form of the overall amount of CO2 at the intracellular pH in the range between 7 and 8. So the protein is very important in the exchange of oxygen and CO2 in the body. The ultimate, the ultimate extensibility of erythrocyte membrane is characterized the ratio of the stiffness of the membrane to its elasticity. This parameter is expressed in terms of the maximum relative increase in the membrane area during erythrocyte lysis. The ultimate extensibility of the membrane is an important parameter for assessing the availability of the red blood cells and their resistance to osmotic lysis. The higher this parameter is, more than red blood cell is transformed. Here you can see that the sorbent aluminum oxide with polydimethylsiloxane reduces the number of active band3 protein to the least extent, and the sorbent SUMS1, the first, cause a decrease in this indicator in red blood cells almost twice as compared to blood after surgery. And the value, the ultimate extensibility of the red blood cells membrane increased 3 times. This probably indicates of the integrity of the membrane and the launch of the cascade of reaction that lead to a change in the throughput of band3 proteins. However, this change is lay between samples don't exceed the normal range measured on 20 donors. As a conclusion, this comparative pilot study of numerical parameters of physiochemical and biological properties of 2 different sorbents obtained on basis of aluminum oxide and various hydrophobic agents, organic silicon, polymer, and carbon. This study conducted by scanning flow cytometry on the effect of sorbents on the biometric parameters of red blood cells in the conditions of gamma perfusion didn't reveal a traumatic effect of sorbents on the parameters of red blood cells in comparison with the red blood cells of the original blood taken from a patient after total joint replacement surgery. But in the case of sorbent with a hydrophobic organic silicon polymer, there was a slight decrease in the hemoglobin content on the blood compared to the carbon mineral sorbent. The same sorbent reduces the number of active band3 proteins to the least extent. The results obtained allow us to conclude that the use of scanning flow cytometry is a perspective method for monitoring of biometric parameters of peripheral erythrocytes and during surgical and blood transfusion exposure. And this method is much promising. I repeat, this is a pilot study, and we continue our investigation. Here you can see our team from Institute of Kinetics and Combustion, and from Research Institute of Clinical and Experimental Lymphology, particularly Pharmaceutical Technology Laboratory of Operative Lymphology and Lymphatic Patient, and Connective Tissue Pathology Laboratory. Thank you for your attention.